In the final lecture of the Introduction to Smoke course, you will be introduced to some techniques for troubleshooting problems with smoke simulations. These techniques involve looking through the smoke scripts and log files for configuration problems and using the smoke manual to confirm the settings and input files for a smoke simulation. Several common smoke processing problems will be presented to provide you with some background on smoke operational issues before you get started on the hands-on exercises. You will learn about the Smoke QA program, Smkreport, for creating customized reports of emissions. After getting some ideas for how to obtain technical support for smoke, you'll be introduced to the details of the training exercises that you will run in the hands-on part of this class. All of the smoke programs output log files. You should check the smoke logs from each program for both successful and unsuccessful smoke runs. The first thing to look for is the normal completion message at the bottom of the log file. If you don't see this message, then the program stopped for some reason. Work from the bottom of the log file to the top. When a smoke program stops because of an error, the error message will be one of the last lines written to the log file. The smoke error handling is pretty good, and most of the errors are informative and help you figure out what went wrong with the simulation. Occasionally, smoke will report an internal error. These are usually the result of a problem in the smoke source code, such as an incorrectly dimensioned array. Internal errors need to be reported to the CMAS Center for resolution. When smoke simulations run to completion, it's important to review all of the warnings in the output log files. Confirm that the warning messages do not result in any unexpected settings or results before proceeding with the results from the smoke simulation. The most common error message in the smoke programs is that a program stops because it cannot find an input file. Check the program log file to make sure that the logical file name that Smoke uses to alias the input file is defined and pointing to an actual file. Confirm the directory path and file name to make sure that they exist on your system. As both the path and file name can become quite long, the best practice is to copy the entire directory and file name string from the Smoke log file and then list the file name by pasting the full path and file name at the command prompt. If the input file is generated by another program, like the Smoke Invin output intermediate file, ensure that the upstream program completed successfully. Another problem that you may see is that Smoke reports that it cannot open an output file. Ensure that the output directory exists and that you have the correct permissions to write to it and to overwrite any files that may already exist in the directory. Another problem that you may encounter when running Smoke is that you can't find the output files from the Smoke programs. The first obvious check is to confirm that the program completed. Check the log file to find out the actual file name and directory path written by the program. The most common reasons for a successful Smoke run to not write output data where you expect it is that the assigns file referenced in the run script is either not the right assigns file or the assigns file itself is not configured correctly. After you've succeeded with all of the Smoke programs and all of the simulations appear to be configured correctly, you'll want to begin using the Smoke QA program, Smkreport. Smkreport creates canned and customized reports of the emissions that you can use to confirm how the inventory data were processed. Note that Smkreport only works for the anthropogenic inventory sources. Smkreport cannot be used to create summaries of biogenic emissions. The central component of Smkreport is the report configuration or rep.config file, which is located in the invdir/other directory in the Smoke installation. The rep.config file uses a specific syntax for defining the contents of the output report files. This slide shows two rep.config packets. On the left, Smkreport is being configured to produce a report of state totals that include the name of the state in the report, the emissions in units of tons per year reported as floating point numbers with 5 digits to the right of the decimal place. In the packet on the right, Smkreport will create a report with a gridding matrix applied to the emissions for a particular modeling grid. It will report emissions by state, county, and 10-digit SCC name. In this report, the units of the emissions are in tons per day, with exponential formatted numbers with 2 digits to the right of the decimal place. Several report types can be defined within one repconfig file. Smoke support. The first place to go for troubleshooting smoke issues is the Smoke User's Manual. The online version of this document is a comprehensive and detailed reference for all of the smoke programs. The EPA Clearinghouse for Inventories and Emissions Factors is a great resource for emissions data, including inventories and ancillary data files. Finally, the M3 User Listserv, which is available through the CMAS Center website, is the go-to online resource for posing technical questions about smoke simulations. If you get stumped with smoke, sign up and post a message or a question to M3 User, and it will be promptly answered by one of the many expert smoke modelers in the emissions modeling community. The Smoke User's Manual, available from smokemodel.org, includes detailed listings of all of the settings, input file formats, and output file formats of the smoke programs. You will be asked to refer to the Smoke Manual during several exercises in the hands-on training labs later in the course. If you will be using Smoke regularly, you'll need to have the Smoke Manual bookmarked in your web browser. It's your primary and go-to resource for questions about smoke. For the rest of this course, you'll be practicing using the smoke programs through a series of hands-on laboratories. The smoke training case is built off an actual research modeling simulation used by the National Park Service as part of the Rocky Mountain Atmospheric Nitrogen and Sulfur, or ROMANS, study. The input data and modeling domains are pared down to speed up the smoke processing. You will use the training case to prepare emissions estimates for all of the criteria pollutants over 2 domains centered on Denver, Colorado. You will produce emissions for a single day, July 7th, 2006. This slide shows the 2 modeling domains that will be used for this training: a 12-kilometer domain over the Intermountain West and a 4-kilometer domain centered on Denver, Colorado. The Smoke Moves exercises use a different domain and set of input files. For the Smoke Move simulation, you will use year 2009 activity inventories and use smoke to estimate all of the criteria pollutants over a 12-kilometer domain centered on the state of Georgia. You will run Smoke Moves for 1 day, April 1st, 2009. This slide shows the image of the 12-kilometer Smoke Moves modeling domain. This concludes the Introduction to Smoke lectures. You can now start on the hands-on training labs, starting with the Overview lab. Begin by reviewing the materials in the course introduction on the Introduction to Smoke website for information on how to log in to the Amazon cloud-based training images.